Hey guys, it's Udbhav from team 19343. This video is a continuation of my FTC programming course in Android Studio. Today's video will be on our first physical component, the servo. This video will include what a servo is, different types of servos, how to code servos, and game-relevant applications of servos. We will be using linear op mode to demonstrate the servo coding. However, the difference between op mode and linear op mode is fairly negligible in this case. But first of all, what is a servo? A servo, in the context of FTC, is essentially a motor that can be set to certain rotation positions. Like a motor, a servo can rotate in a set direction. However, a normal servo does not continually rotate and instead can be set to a certain position within a range of degrees. So for example, a 180-degree servo set to 0.5 will rotate 90 degrees. Servos are often used in intake and outtake mechanisms, such as claws, droppers, outtake rotators, and more. There are two types of servos: normal servos, with set degree ranges, and CR servos, or continuous rotation servos, which are essentially like smaller motors. Servos are not used for heavy loads, such as in drivetrains, and they are generally not very large and lack the power of motors. Let's move on to the coding aspect of servos. Alright, let's go ahead and initialize the servo. Now let's hardware map it. And let's name it servo 1. This is how we're going to initialize a majority of the components. So for example, later in the course, we'll be doing the same thing with the motor. Alright, so now that we've initialized the servo, let's go ahead and give it a command. So the most simple and basic command we can give to a servo is to set its position, like we discussed earlier in the video. So let's go ahead and do that. So servo 1, set position, let's say 0.5. Taking another command we can give to the servo is a scale range command. So for example, let's go up, back to wait for start. Servo 1 dot scale range. So this will essentially give our range for the servo to operate in. So for example, let's say we keep 0.2, comma 0.8. So now these are the maximum values that the servo can go to. However, let's not mistake it to the fact that we cannot set this past 0.8 or 0.2. As you can see, we still can. However, what scale range does is instead reduce the total number of degrees that the servo will rotate. So for example, 0.2 is now our new set position 0. And 0.8 is our new set range 1. So these CR servos are generally utilized for parts that require a continuous rotation motor but lack the designated space for a fully fledged motor. So for example, in a smaller roller-based intakes, part of the mechanism may utilize CR servos. Finally, let's speak about coding the continuous rotation servo. The continuous rotation servo is coded in the same manner as the normal servo. Let's initialize, hardware map, and then give it a command. Let's go ahead and do that. So CR servo 1. Now let's hardware map it. Get CR servo class. Oops. And let's name it once again CR servo 1. So, as the name might imply, continuous rotation servos continuously rotate just like a motor. So this is why instead of setting a position to the continuous rotating servo, we set a power at which it rotates. So basically it increases or decreases the RPM. So CR servo 1 dot set power, let's say 0.5. Servos are extremely useful and necessary components that many top-level teams utilize to perform functions. In this year's game, Into the Deep, the servo can be used for handling the sample and specimen in both intakes and outtakes. Placing the specimen on the rung and samples into the bin require a set position for the servos. So here we can utilize the simple set position command for the servos. That's it for today's video on servo coding and uses for FTC Java programming. I hope that you now have a comprehensive understanding of the uses of servos, their different types, and how to code the same. Remember, the most complicated mechanism is rarely the one that wins. It's always the most simple and intuitive parts that make the biggest difference. Stay tuned for the next video in which we will learn how to program motors. This is Udbhav from Team 19343 signing off.